Dmitri Ivanovich Mendeleev. February 8, 1834 Euro February 2, 1907 OS. 27 January 1834 Euro January 20, 1907, was a Russian chemist and inventor. He formulated the periodic law, created his own version of the periodic table of elements, and used it to correct the properties of some already discovered elements and also to predict the properties of 8 elements yet to be discovered. Early life: Mendeleev was born in the village of Verkhnye-Rimzyany, near Tobolsk in Siberia, to Ivan Pavlovich Mendeleev and Maria Dmitryevna Mendeleeva. His grandfather was Pavel Maximovich Sokolov, a priest of the Russian Orthodox Church from the Tver region. Ivan, along with his brothers and sisters, obtained new family names while attending the theological seminary. Mendeleev was raised as an Orthodox Christian, his mother encouraging him to patiently search divine and scientific truth. His son would later inform that he departed from the church and embraced a form of deism. Mendeleev is thought to be the youngest of either 11, 13, 14 or 17 siblings. The exact number differs among sources. His father was a teacher of fine arts, politics and philosophy. Unfortunately for the family's financial well-being, his father became blind and lost his teaching position. His mother was forced to work and she restarted her family's abandoned glass factory. At the age of 13, after the passing of his father and the destruction of his mother's factory by fire, Mendeleev attended the gymnasium in Tobolsk. In 1849, his mother took Mendeleev across the entire state of Russia from Siberia to Moscow with the aim of getting Mendeleev a higher education. The university in Moscow did not accept him. The mother and son continued to St. Petersburg to the for their unregistered trademark S alma mater. The now poor Mendeleev family relocated to St. Petersburg, where he entered the main pedagogical institute in 1850. After graduation, he contracted tuberculosis, causing him to move to the Crimean Peninsula on the northern coast of the Black Sea in 1855. While there he became a science master of the Simferopol Gymnasium A-1. He returned with fully restored health to St. Petersburg in 1857. Later life: between 1859 and 1861, he worked on the capillarity of liquids and the workings of the spectroscope in Heidelberg. In late August 1861 he wrote his first book on the spectroscope. On 4 April 1862 he became engaged to Fyodor Nikitokna, and they married on 27 April 1862 at Nikolov Engineering Institute's church in St. Petersburg. Mendeleev became a professor at the St. Petersburg Technological Institute and St. Petersburg State University in 1864 and 1865, respectively. In 1865 he became Doctor of Science for his dissertation on the combinations of water with alcohol. He achieved tenure in 1867, and by 1871 had transformed St. Petersburg into an internationally recognized center for chemistry research. In 1876, he became obsessed with Anna Ivanovna Popova and began courting her. In 1881 he proposed to her and threatened suicide if she refused. His divorce from Leshkeva was finalized 1 month after he had married Popova in early 1882. Even after the divorce, Mendeleev was technically a bigamist. The Russian Orthodox Church required at least 7 years before lawful remarriage. His divorce and the surrounding controversy contributed to his failure to be admitted to the Russian Academy of Sciences. His daughter from his second marriage, Lyubov, became the wife of the famous Russian poet Alexander Blok. His other children were son Vladimir and daughter Olga, from his first marriage to Fyodor, and son Ivan and twins from Anna. Though Mendeleev was widely honored by scientific organizations all over Europe, including the Davy Medal from the Royal Society of London, he resigned from St. Petersburg University on 17 August 1890. Mendeleev also investigated the composition of petroleum, and helped to found the first oil refinery in Russia. He recognized the importance of petroleum as a feedstock for petrochemicals. He is credited with the remark that burning petroleum as a fuel would be akin to firing up a kitchen stove with bank notes. In 1905, Mendeleev was elected a member of the Royal Swedish Academy of Sciences. The following year the Nobel Committee for Chemistry recommended to the Swedish Academy to award the Nobel Prize in Chemistry for 1906 to Mendeleev for his discovery of the periodic system. The chemistry section of the Swedish Academy supported this recommendation. The Academy was then supposed to approve the committee choice as it has done in almost every case. Unexpectedly, at the full meeting of the Academy, a dissenting member of the Nobel Committee, Peter Claesson, proposed the candidacy of Henri Moissan whom he favored. Svante Arrhenius, although not a member of the Nobel Committee for Chemistry, had a great deal of influence in the Academy and also pressed for the rejection of Mendeleev, arguing that the periodic system was too old to acknowledge its discovery in 1906. According to the contemporaries, Arrhenius was motivated by the grudge he held against Mendeleev for his critique of Arrhenius's dissociation theory. After heated arguments, the majority of the Academy voted for Moissan. The attempts to nominate Mendeleev in 1907 were again frustrated by the absolute opposition of Arrhenius. In 1907, Mendeleev died at the age of 72 in St. Petersburg from influenza. The crater Mendeleev on the Moon, as well as element number A101, the radioactive Mendeleevium, are named after him. Periodic table. In 1863 there were 56 known elements with a new element being discovered at a rate of approximately 1 per year. Other scientists had previously identified periodicity of elements. John Newlands described a law of octaves, noting their periodicity according to relative atomic weight in 1864, publishing it in 1865. His proposal identified the potential for new elements such as germanium. The concept was criticized and his innovation was not recognized by the Society of Chemists until 1887. Another person to propose a periodic table was Lothar Meyer, who published a paper in 1864 describing 28 elements classified by their valence, but with no prediction of new elements. Meyer, who is often credited with the discovery of the periodic system, opposed and criticized the periodic law. After becoming a teacher, Mendeleev wrote the definitive textbook of his time, Principles of Chemistry. As he attempted to classify the elements according to their chemical properties, he noticed patterns that led him to postulate his periodic table. He claimed to have envisioned the complete arrangement of the elements in a dream. "I saw in a dream a table where all elements fell into place as required. Awakening, I immediately wrote it down on a piece of paper, only in one place did a correction later seem necessary." Unaware of the earlier work on periodic tables going on in the 1860s, he made the following table. By adding additional elements following this pattern, Dmitri developed his extended version of the periodic table. On March 6, 1869, Mendeleev made a formal presentation to the Russian Chemical Society, entitled The Dependence Between the Properties of the Atomic Weights of the Elements, which described elements according to both atomic weight and valence. This presentation stated that, the elements, if arranged according to their atomic weight, exhibit an apparent periodicity of properties. Elements which are similar regarding their chemical properties have atomic weights which are either of nearly the same value or which increase regularly. The arrangement of the elements in groups of elements in the order of their atomic weights corresponds to their so-called valences, as well as, to some extent, to their distinctive chemical properties. As is apparent among other series in that of Li, B, C, N, O, and F. The elements which are the most widely diffused have small atomic weights. The magnitude of the atomic weight determines the character of the element, just as the magnitude of the molecule determines the character of a compound body. We must expect the discovery of many yet unknown elements for example, two elements, analogous to aluminium and silicon, whose atomic weights would be between 65 and 75. The atomic weight of an element may sometimes be amended by a knowledge of those of its contiguous elements. Thus the atomic weight of tellurium must lie between 123 and 126, and cannot be 128. Here Mendeleev seems to be wrong as the atomic mass of tellurium remains higher than that of iodine as displayed on modern periodic tables, but this is due to the way atomic masses are calculated, based on a weighted average of all of an element's common isotopes, not just the 1-to-1 proton-neutron ratio version of the element to which Mendeleev was referring. certain characteristic properties of elements can be foretold from their atomic weights. Mendeleev published his periodic table of all known elements and predicted several new elements to complete the table. Only a few months after, Mayr published a virtually identical table. Some consider Mayr and Mendeleev the co-creators of the periodic table, but virtually everybody agrees that Mendeleev's accurate prediction of the qualities of what he called ecosilicon, icaluminium and icaboron qualifies him for the majority of the credit for the table. For his predicted 8 elements, he used the prefixes of icar, vi, and tri in their naming. Mendeleev questioned some of the currently accepted atomic weights, pointing out that they did not correspond to those suggested by his periodic law. He noted that tellurium has a higher atomic weight than iodine, but he placed them in the right order, incorrectly predicting that the accepted atomic weights at the time were at fault. He was puzzled about where to put the known lanthanides, and predicted the existence of another row to the table which were the actinides, which were some of the heaviest in atomic mass. Some people dismissed Mendeleev for predicting that there would be more elements, but he was proven to be correct when Ga and Ge were found in 1875 and 1886 respectively, fitting perfectly into the 2 missing spaces. By giving Sanskrit names to his missing elements, Mendeleev showed his appreciation and debt to the Sanskrit grammarians of ancient India, who had created sophisticated theories of language based on their discovery of the 2-dimensional patterns in basic sounds. Mendeleev was a friend and colleague of the Sanskritist Bar Paragraph-Link, who was preparing the 2nd edition of his book on power to the first ni at about this time, and Mendeleev wished to honor power to the first ni with his nomenclature. Noting that there are striking similarities between the periodic table and the introductory shivas in power to the first ni's grammar, Professor Kiparsky says, "The analogies between the 2 systems are striking. Just as Panini found that the phonological patterning of sounds in the language is a function of their articulatory properties, so Mendeleev found that the chemical properties of elements are a function of their atomic weights." Like Panini, Mendeleev arrived at his discovery through a search for the grammar of the elements. The original draft made by Mendeleev would be found years later and published under the name Tentative System of Elements. Other achievements: Mendeleev made other important contributions to chemistry. The Russian chemist and science historian Lev Shugov has characterized him as a chemist of genius, first-class physicist, a fruitful researcher in the fields of hydrodynamics, meteorology, geology, certain branches of chemical technology and other disciplines adjacent to chemistry and physics, a thorough expert of chemical industry and industry in general, and an original thinker in the field of economy. Mendeleev was one of the founders, in 1869, of the Russian Chemical Society. He worked on the theory and practice of protectionist trade and on agriculture. In an attempt at a chemical conception of the ether, he put forward a hypothesis that there existed 2 inert chemical elements of lesser atomic weight than hydrogen. Of these 2 proposed elements, he thought the lighter to be an all-penetrating, all-pervasive gas, and the slightly heavier one to be a proposed element, coronium. Mendeleev devoted much study and made important contributions to the determination of the nature of such indefinite compounds as solutions. In another department of physical chemistry, he investigated the expansion of liquids with heat, and devised a formula similar to Gay-Lussac's law of the uniformity of the expansion of gases, while in 1861 he anticipated Thomas Andrews' conception of the critical temperature of gases by defining the absolute boiling point of a substance as the temperature at which cohesion and heat of vaporization become equal to 0 and the liquid changes to vapor, irrespective of the pressure and volume. Mendeleev is given credit for the introduction of the metric system to the Russian Empire. He invented pyrocolloidin, a kind of smokeless powder based on nitrocellulose. This work had been commissioned by the Russian Navy, which however did not adopt its use. In 1892 Mendeleev organized its manufacture. Mendeleev studied petroleum origin and concluded hydrocarbons are abiogenic and form deep within the earth see abiogenic petroleum origin. He wrote, "The capital fact to note is that petroleum was born in the depths of the earth, and it is only there that we must seek its origin." The Vodka Myth, A very popular Russian story is that it was Mendeleev who came up with the 40% standard strength of vodka in 1894, after having been appointed director of the Bureau of Weights and Measures with the assignment to formulate new state standards for the production of vodka. The story has, for instance, been used in marketing claims by the Russian Standard vodka brand that, in 1894, Dmitri Mendeleev, the greatest scientist in all Russia, received the decree to set the imperial quality standard for Russian vodka and the Russian standard was born, or that the vodka is compliant with the highest quality of Russian vodka approved by the Royal Government Commission headed by Mendeleev in 1894. While it's true that Mendeleev in 1892 became head of the Archive of Weights and Measures in St. Petersburg, and evolved it into a government bureau the following year, that institution was never involved in setting any production quality standards, but was issued with standardizing Russian trade weights and measuring instruments. Furthermore, the 40% standard strength was introduced by the Russian government already in 1843, when Mendeleev was 9 years old. The basis for the whole story is a popular myth that Mendeleev's 1865 doctoral dissertation, A Discourse on the Combination of Alcohol and Water, contained a statement that 38% is the ideal strength of vodka, and that this number was later rounded to 40% to simplify the calculation of alcohol tax. However, Mendeleev's dissertation was about alcohol concentrations over 70% and he never wrote anything about vodka. Commemoration: a number of places and objects are associated with the name and achievements of the scientist. In St. Petersburg his name was given to the National Metrology Institute dealing with establishing and supporting national and worldwide standards for precise measurements. Next to it there is a monument to him pictured above that consists of his sitting statue and a depiction of his periodic table on the wall of the establishment. In the 12 Collegia building, now being the center of St. Petersburg State University and in Mendeleev's time a head pedagogical institute there is Dmitri Mendeleev's Memorial Museum apartment with his archives. The street in front of these is named after him as Mendeleevskaya Linia. In Moscow, there is the Mendeliev University of Chemical Technology of Russia. After him was also named mendelevium, which is a synthetic chemical element with a symbol Md and the atomic number 101. It is a metallic radioactive transuranic element in the actinide series, usually synthesized by bombarding Einsteinium with alpha particles. A large lunar impact crater Mendeleev that is located on the far side of the Moon, as seen from the Earth, also bears the name of the scientist. Russian Academy of Sciences yearly awards since 1998 Mendeleev Golden Medal for achievements in chemical science and technology. See also: List of Russian chemists, Mendeleev's predicted elements, periodic systems of small molecules, references. Further reading: Gordon, Michael. A Well-Ordered Thing, Dmitri Mendeleev and the Shadow of the Periodic Table. New York, Basic Books. ISBN A0-465-02775-X. Mendeleev, Dmitri Ivanovich. Jensen, William B. Mendeleev on the Periodic Law, Selected Writings, 1869 1905. Mynera, New York, Dover Publications. ISBN A0-486-44571-2. Strathan, Paul. Mendeleev's Dream, The Quest for the Elements. New York, St. Martin's Press. ISBN A0-241-14065-X. Mendeleev, Dmitri Ivanovich. Principles of Chemistry. New York, Collier, External Links, Original Periodic Table, Annotated. Mendeleev's first draft version of the Periodic Table, February 17, 1869. Everything in its Place, essay by Oliver Sacks, works by or about Dmitri Mendeleev in libraries.